Good evening. Hello everyone. I hope you have started solving problems from arithmetic progression and geometric progression. Because in past few sessions I have tried to cover the concept of AP and GP which you need for your school-based examination. AP problems also solved and I showed you how to start. This session, get ready to start GP sums with me. I'll be telling you step by step how to solve geometric progression sums. I'll be discussing some difficult sums also. But before that, I'd like to revise the geometric progression concept and formula. Stay focused till the end of this session. Let us start geometric progression revision work and then sums from geometric progression. So standard geometric progression, the way I have taken here, you remember it. A geometric progression can be taken as AR square this manner. We have referred this A as the first term and R the common ratio. For example, if we take it this manner, 4, 12, 36 like this, then the first term is 4 and common ratio is 3, isn't it? Because if you multiply by 3 you get the next term of the arithmetic of the geometric progression or geometric sequence. For this geometric sequence we found nth term. What is the formula for nth term? Nth term Tn equal to A into R to the power n minus 1. This you know. Nth term formula. A is the first term, R is the common ratio, and we found, suppose we want to do it for this problem, we want to find T10. This will be what? 4 into 3 to the power 10 minus 1. So it is 4 into 3 to the power 9. But we are discussing about the standard GP. It is AR to the power n minus 1. The sum up to n terms. Sum of n terms is given by Sn. This is A into 1 minus R to the power n by 1 minus R when R less than 1, and A into R to the power n minus 1 by R minus 1 when R greater than 1. I also told you for R equal to 1 this formula are not valid. In that case Sn is sum of these terms A this way up to n times, isn't it? So this is going to be equal to n into A. Hope you understand. The sum of n terms of geometric progression is done. Then we did that sum of infinite GP. What is an infinite GP? For an infinite GP, AR square series will converge up to infinity and the common ratio should be explained. Nth term we find by this formula, no problem, but how to find the sum of this I have explained. S up to infinity, infinite number of terms, their sum will be A by 1 minus R. These are the formula available in GP, and another one that in a geometric progression between two terms, if we have inserted two means, one mean first, then you get geometric mean. Geometric mean or GM between A and B is defined as G equal to root AB. Okay? Obviously this A, G, B are in GP, isn't it? Because G by A and B by G, they will carry the same ratio. So G equal to root over AB is the geometric mean between A and B. What is the concept of n geometric means? Concept of n GMs. What is the concept? For n geometric means, if we insert between A and B, then A, those means G1, G2, Gn, B are in GP, and we have proved that G1 into G2 into G3 up to Gn, this product is going to be root AB to the power n. You agree? That is single geometric mean to the power n. See, what is the application of this thing? This is a very useful theorem or property, whatever you say. I am just asking you, between two numbers 4 and 64, say 40 geometric means are inserted. 40 GMs are inserted between 4 and 64. Okay? Then what is the product of those 40 geometric means? That G1, G2, G40 will be 40th power of single geometric mean. Single geometric mean is what? G, that is root over 4 into 64, both are positive, so this will be 16. So the result going to be 16 to the power 40. This theorem is very powerful because you are multiplying all the geometric means without actually multiplying. The result going to be single geometric mean to the power 40. Remember this? Probably I have also told you, if three numbers in GP, they can be taken as three numbers in GP, A by R, A, AR. Why? Because their product will be a cube then. If three numbers in GP, it will be like this. If 5 numbers are in GP, they can be taken as A by R square, A by R, A, AR and AR square. Why? The logic is similar. Why? Because their product will give you a term which is free of R. So these kind of sums, when they ask, normally they say that product of 3 terms or 5 terms like this, find the terms. You have to take it this manner. If you take it in the form A, AR, AR square, it will take time to solve for you. Next, number 3. If 4 numbers are in GP, they can be taken as A by R cube, A by R, AR and AR cube. Clear? You can take terms this manner. Okay? Now let us start solving problems from geometric progression. I have kept some sums ready for you. You all be ready with your pen and paper to solve it with me. Okay? Find the number of terms in the GP 3, 6, 12, 192. How many terms are there in this GP? This we are going to find. How will you find it? Number of terms in GP is 36292. Very simple problem. We can start this manner. Let Tn equal to 192. What is A here? Here A is 3. And common ratio is what? Common ratio equal to 2. Isn't it? Now, this Tn equal to 192. Tn formula is what? A r to the power n minus 1. This is 192. 3 into 2 to the power n minus 1. Therefore, 2 to the power n minus 1 is 64. 192 by 3 is 64. This is nothing but 2 to the power 6. So this implies n minus 1 equal to 6. Therefore, n equal to 7. Not a difficult sum, because you've just found the number of terms of this geometric progression by assuming the last one as the Tn. Let us do second one. Second term of a GP is 6. Fifth term is 162. Find the GP. You have to find the GP. Finding GP means you have to find the common ratio and the first term. Isn't it? You just find the common ratio and first term, then everything is done. Second term of a GP is 6. So, if you take the GP this manner, AR square, AR cube, then T2 is equal to 6. T2 is what? AR. This is number 1. Fifth term is what? 162. AR to the power 4 is equal to 162. You just solve for A and R. Okay? You can easily find it, the value of both A and R. How to? Because when you divide 2 by 1, dividing 2 by 1, what do you get? AR cube, AR to the power 4 by AR equal to 162 by 6. Isn't it? This is 162 by 6. This is nothing but 27. So R cube 27. This implies that R equal to 3. And from 1, put R equal to 3. A into 3 equal to 6. So A going to be equal to 2. So GP is done. Its first term is 2 and the common ratio is equal to 3. If they ask you to find a 10th term or 12th term, then you use the formula Tn equal to r to the power n minus 1. Isn't it? Oh, that sum is only we did. Now next one, sum of an infinite GP is 12. Sum of the squares of its terms is 48. Find the first term and the common ratio. Sum of an infinite GP is 12. Infinite GP I have explained. What is the sum of infinite GP? Let A be the first term, R less than 1 is the common ratio. Sum of infinite GP is what? A by 1 minus R, you know. R is always less than 1. This is 12. So you have taken the GP this manner, AR square this way up to infinity. For that the sum is A by 1 minus R equal to 12. Sum of the squares. Sum of the squares is what? A square R square up to infinity. What is the sum of this progression? A square by 1 minus R square. This is equal to what? This is 12. Am I correct? This is 12, no, sorry. This is 48. It's given, this is 48. Number 2. Your problem is to solve A and R. How to? If you only divide, then it will not come. So it is better you do this way. You write this as A by 1 minus R, A by 1 plus R equal to 48. Why? Because A by 1 minus R is 12. So 12 into A by 1 plus R is 48. Therefore, A by 1 plus R, 48 by 12. 48 by 12 is how much? A by 1 plus R. This is 4. So you got A by 1 minus R equal to 12. You got A by 1 plus R equal to 4. It's fine. What is the value of A and R? To get it, we just divide this 1 by 3 or 3 by 1. Just do it. Dividing 1 by 3 or 3 by 1. These equations you got here. So just dividing 1 by 3. A by 1 minus R. This is equal to 12 by 4. So this implies you take this one up, A and A, you strike it out. This A and this A will get will be cancelled. It will be 1 plus R by 1 minus R equal to 3. Clear? Now just cross multiply and do it. So this implies 4R equal to, so R equal to 2 by 4, this is 1 by 2. Clear? So the value of R is equal to 1 by 2. Then you can get value of A. You just put the value of R there. From 3, put R over there. A by 1 plus half equal to 4. So answer is equal to 6. Okay. So you got r equal to half and a equal to 6. If you get a and r, then the series is done. They ask you to find the first term and the common ratio. We got it. Go for next one. This is GP again, not infinite GP. And we are not solving any difficult sum here. You are just practicing with me. You are doing it with me here. So I hope that you are completing all sums before I complete here. That's why I'm not doing very fast, isn't it? See, fifth term of a GP 48, sum of the first three terms 21. Find the first term and the common ratio. What will you do? This is not infinite GP, and those special way we have considered GP, A by R, A, AR like that, when product of terms given. Here product not given. So you have the right to consider it the way you like. Okay? Fifth term of GP is 48. So I am not solving this sum fully. That T5, you write AR to the power 4. This is given 48. And sum of three terms, A plus AR plus AR cube is 21. This is given. You have to solve A and R from there. Clear? You understand how to solve? You just divide. There will be equation containing R. Then put the value of R. You can get the value of A from there. Don't do any trial and error method. Complete the sum at home. This is ordinary sum. Do next one. If the continuous product of three terms in GP is 216, sum of their product in pairs 156, find the numbers. Not a difficult sum. Continuous product of three terms in GP 216. So three terms in GP we take that way. Let terms be A by R, A, AR, isn't it? You take three terms this manner. Why? Because product is given 216. As product equal to 216, therefore A by R, A into AR, 216. So A cube equal to 6 cube. We got A equal to 6. Okay? This is the advantage of considering terms this manner. Now product in pairs is what? Product in pairs, A by R into A into AR into A by R. No other possible product is there. We have taken all the products possible among these three in pairs, and then I am writing their sum equal to 156. It is given, and you know the value of A. You take A square common, 1 by R plus 1, 156, isn't it? So this implies 1 R square R by R equal to 156 by A square, 6 square. That is 1 get cancelled, 26, isn't it? You have to solve for R from there. Clear? You have to solve for R from this. 1 6 getting cancelled. You take another one, cancel 13, and this is 3. Understand what I did there? It is 156 by a square. A square is what? 6 into 6. So if you cancel with 6, 36, and then by 2, 3 and 13. So here you got 13 by 3. Therefore, 3r square, 3r minus 13r equal to 0. Clear? From here, you have to solve the value of r. So this is going to be, you understand, you all understand? 3r square minus 10r plus 3 equal to 0. So this implies 3r square minus 9r minus r plus 3 is 0. R minus 3 minus 1. I have taken common sums only. Okay. I have used my experience of teaching this GP, and I am taking those kind of sums which, when you start solving GP sums from your book, will help you. Only I will tell you, you practice these sums with me here so that you can realize the mistake and then do again. Clear? So R I got 3 and 1/3. A I got earlier, A 6. R3, one option. The other option is A6 and R equal to 1/3. Clear? So series of terms are like A by R, A and AR. So in this case, series of terms will be what? A by R, A, AR. A by R is what? 6 by, this is R equal to 3, no? This is R. So A by R is what? 2, 6 and 18. Clear? If you take this manner, are you wrong? No. A by R you write? Then A. And then A into R. This is equal to 18, 6, 2. Clear? This way, it can be done. So those three numbers are coming only, but in opposite order. 268 or 1862. Understand? Go for next one. Not a difficult sum, similar. I am just adding the equation so that you can start at home. Sum of an infinite GP, that A by 1 minus R equal to 5, and the first term is given 3. So 3 by 1 minus R equal to 5. I have given this practice sum. Why, you know? So R equal to 2 by 5. Now suppose R is equal to 5 you got, or 3 you got. Can this be the answer? No. R can never be greater than 1. For an infinite GP, R is always less than 1. Let us go for next one. Pth, qth, rth term of a GP are what? Pth, qth, rth term of an AP are in GP. So that common ratio is this. All of you can see the sum. See how to answer it. Pth, qth and rth term of AP are in GP. So for that AP, you start this manner. Let A be the first term and D the common difference. Okay? D be the common difference. So TP is what? Pth term is what? A plus p minus 1d, a plus q minus 1d, a plus r minus 1 into d. Now, these three terms are in GP. These three terms are in GP. Then what is your problem? These three terms are in GP. You have to find the common ratio. Okay? They're in GP. What's the condition? As TP, TQ, TR are in GP, we take TQ by TP equal to TR by TQ equal to the common ratio RC, RR. Small r is given there, so I am not taking that. So TQ is A plus Q minus 1D by A plus P minus 1D equal to R, and then TQ by TP and TR by TQ. What is TR? A plus R minus 1D by A plus Q minus 1D is equal to R. Am I correct? You all understand? But this one is a tricky sum, not so easy to get, because see, from these two equations, if I have to eliminate, then it is huge, isn't it? You have to use some technique. What technique? You just cross multiply. A plus Q minus 1 into D equal to R into, isn't it? Now take all A's together. RA you take on left side and Q minus 1D on right side. Do I need to expand it? Okay, doing it step by step. I have taken a complicated sum for you. Don't say complicated, a good sum for you. AR plus RDP minus 1, isn't it? Now take all R's on one side, all A's. So A into 1 minus R equal to D R into P minus 1 minus Q minus 1, isn't it? We got this equation. Take this one as number 3. Clear? Now I will be using the second condition also the same manner. Okay? So this time Q will be replaced by R and P will be replaced by Q. Then go on dividing, R will come out. Believe me, it will come. So you do it here. A into R minus 1D equal to R into A plus, hope you are doing it with me. Otherwise, it will be done by me only. You agree or not? You have to do it with me. Since board is clearly visible, it is your duty to finish before I do it here. In the similar fashion, you take AR on left side. 1 minus R will be D into RQ minus 1D minus R minus 1. Clear? Will you get? Will you get the answer or not? Definitely you will get the answer if you don't do any mistake. See, left hand side we got the same thing, a into 1 minus r. So right hand sides must be equal, or compare 3 and 4. From 3 and 4, d p minus 1 minus q minus 1 d r q minus 1 minus r minus 1. dd get cancelled. Your problem is to get the value of r. So open the bracket and take the r on same side. It will be what? R into p minus 1 minus q minus 1 r into q minus 1 minus r minus 1. This and this you take together on the left hand side. So r into p minus 1 minus q minus 1 going to be, this you take on right side. Am I correct? Just take it on the right side. So this implies what? R into P minus Q equal to Q minus R. Therefore, common ratio is becoming Q minus R by what? Q minus R by P minus Q. It's a big one, but I have done. Q minus R by P minus Q. Exactly same answer I got. Okay? So hope you have understood. This is bit difficult sums, but this is a common sum. Believe me, most of the books this sum is there. So this session meant for that, where by practicing with me here, you can start sums from any study material. Start. I haven't told you that you will be so efficient that you can do all sums. Forthcoming session I will be discussing summation of series. Many sums I will bring. Telescoping series also I will explain. Okay? And then more difficult problems on AP, GP mixed. HP also some sums will be there, but wait for that. This session going to be continued. This episode going to be continued on progression. So many things are there to share with you, you won't believe. Do number 8. This is 7 part. Sorry. This is a bit difficult sum. Don't think so. I will be doing one only for you. S1, S2, S3 respectively the sum of n, 2, n3 in terms of a GP. Then prove that S1, S3 minus S2 equal to S2 minus S1 whole square. And S1 square plus S2 square equal to S1 into S2 plus S3. Sum is there in most of the books. Believe me, this type of sums there in all study material in this world. So think and do before I complete here. Okay? So let's start. S1, S2, S3 respectively. See, this is a skill based problem. You don't have to use your brain here, just formula based. You should be capable of continuing steps. Then only the sum will terminate. This is GP given. You start the GP this manner. Let A be the first term and R the common ratio. Okay? R is the common ratio. Then S1 going to be what? Take R greater than 1 because this is not infinite GP. You can take anything. This by r minus 1. S2 is what? Two n minus 1 by r minus 1, sum of 2n terms, r to the power 3n minus 1 by r minus 1. Okay, these are all given. What you will do there, as this is descriptive one, MCQ also may be given which option is correct. This. You have to verify it all or substitute the value. S1, S2, S3 you put, they asked you to prove. Prove it. One of it you can prove. I am in favor of proving which one? Any one. I am doing first one at this moment. LHS is S1 into S3 minus S2. What is S1? R to the power n by r minus 1, and S3 minus S2 you can see S2 will be what? Am I clear? You all understand? I hope so. You have understood. What S1, S2 given over there, based on that I am calculating the left hand side. So it is A into r minus 1. Then you take A by r minus 1 common. What will you get there? Three n minus 1, 2n plus 1. So these two getting cancelled. So there will be a square by this multiplied by, from these two you take r to the power 2n common. Am I correct? So what does it give on simplification? A square into whole square by, am I correct? I found the left hand side. We need to prove this is S2 minus S1 whole square. Let us find S2 minus S1. What we got there, we'll get it back here. How? You just take S2 minus S1. Okay? And then show that this thing equal to, this thing is equal to the right hand side. RHS, this was LHS. RHS should be what? S2 minus S1 whole square. Am I correct? This thing whole square. So this is going to be r minus 1 common, so there will be a into this minus 1 plus 1, strike it out. From these to take r to the power n common. This divided by r minus 1 whole square. What do you get here? Same thing. A square r to the power 2n, r to the power n minus 1 whole square by, am I correct? So this way you have proved that LHS equal to RHS. That is S1 into S3 minus S2 equal to S2 minus S1 whole square. All the best for this part. You should try at home. S1 square plus S2 square equal to S1 into S2 plus S3. Let me discuss other types of sums here. This is a very interesting one, important for all kind of examinations, even in school-based examinations can be asked. See the question, 1 GMG and 2 arithmetic means P and Q be inserted between any two given numbers, then show that G square equal to 2P minus Q into 2Q minus P. I am taking only common sums, I told you. It is there in all books. See, I am doing it. 1 GMG, 2 arithmetic means PQ be inserted between any two given numbers. What are those numbers? Not given. And the condition they have asked you to prove, you can see that those two terms are not there. Only this single mean and those two means are there. Okay? So let us start this manner. Let two numbers be x and y. Those two numbers. Then you know geometric mean is root over x into y. This is number 1. And two arithmetic means between x and y inserted. So these four terms are in GP. Okay? These four are in GP. No, they are in AP. Most of the students do mistake like me. They are in AP given. These four terms are in AP. Two arithmetic means PQ inserted. Okay? So what you have to do there? You have to eliminate x and y. Can't you see that they are in AP? They are in AP. It means what? As they are in AP, this implies Q minus P equal to y. Common difference. Common difference. I have written that only. Isn't it? This minus this equal to this minus this equal to this minus this. So what does this imply from here? X we can get. X is what? X is unknown. No, we have to eliminate. This value of x and y will get here. We will substitute. X going to be what? Transfer it here. That will be 2p minus q. And from these two, what is y? Y is 2q minus p. Clear? So from here, g square equal to xy. This implies g square equal to 2p minus q multiplied by 2q minus p. It is proved. See, it is not difficult sum at all. If you successfully use the given condition, you can get any sum answer. Isn't it? So this one also done. Let us go for the next problem. If A in geometric means be inserted between A and B, then prove that their product is AB to the power n by 2. A in geometric means are inserted between A and B. This sum partly done by me in previous session. Isn't it? A in geometric means inserted between A and B. The geometric means you take this manner. Gn and B. These G1, G2, G3, Gn, they are the means. They are taken in between A and B. Okay? then product of G1, G2, Gn is required. How to answer this? By definition of means, these are in GP. Which term is B here? 1, and these n terms plus 1. So B is Tn plus 2. Isn't it? N terms in between, this plus 1 plus 1. So what does this imply? You assume that R be the common ratio here. R be the common ratio. You assume this. Okay? So B will be what? A the first term, n plus 2th term is B. Am I correct? Isn't it? So R to the power n plus 2 equal to B by A. Am I correct? You understand? R to the power n plus 2 equal to B by A. This is a very important sum to solve MCQ. A in geometric means we inserted between A and B, then prove that their product is AB to the power n by 2. Okay? You can remember this as formula also. I told you earlier also. So R is what here? B by A to the power 1 by n plus 2. Isn't it? What is the advantage of getting R? Now we can write the value of G1. Isn't it? G1 means the first mean. How will I write this? Common ratio we have assumed. G1 is going to be AR. G2 is going to be what? The second mean means third term. It is AR square. This way Gn going to be which term? N plus 1th term. This will be AR to the power n. Understood? So G1, G2, Gn in terms of A and R written, and R is given by this relation. Isn't it? So now G1, G2, Gn, this product going to be what? AR square, AR to the power n. What does it give? A is there, A is there, A is everywhere in these n terms. So A into A into A, this way we will get n times this multiplied by R square, R to the power n. They are multiplied means indices will be added plus n. So this is going to be what? A n times their product will be A to the power n, and R to the power this thing will be n into n plus 1 by 2. Isn't it? So one mistake I did, no one pointed out. This is n plus 1, isn't it? N plus 1. This is n plus 1. Okay? Why? Because I have seen I am not getting the sum without that. So I identify my mistake myself. So to prove that their product is AB to the power n by 2, I am taking this value of R here and substitute. This is therefore the product G1, G2 up to Gn going to be A to the power n, R to the power this means 1 by n plus 1. Am I correct? 1 by n plus 1, n into n plus 1 by 2. This n plus 1 get cancelled. Isn't it? Check whether we have got or not. We have to get ab to the power n by 2. See, it's coming. A into b to the power n by 2. So product of n geometric means inserted between two numbers a and b is product of these two to the power n by 2. Have you made one more observation here? This is nothing but ab to the power half to the power n. This ab to the power half is what? It is single mean. So g to the power n. G is the single geometric mean. This is what? Root ab. Root ab means ab to the power half. And we got g1, g2, g3, gn. Their product is ab to the power half to the power n or g to the power n. In case of arithmetic progression, what we have proved? Sum of those means is n times the single mean. Okay? Understood? Now let us go for this. Find all numbers x, y such that they form an AP while these numbers form a GP. Find all numbers x and y. So that these forms an AP. As they form an AP, you can write the condition easily. What is the condition? All numbers x, y such that they form an AP. What is the condition there? Tell. X, x plus y, 2x plus y forms an AP. Find all the numbers x, y such that they form an AP while these numbers form a GP. I give you the clue. You can solve it now because almost the time to leave you today. Just giving you the clue. They form an AP. You write the condition that twice the middle term is equal to first plus third. Okay? 2 into x plus y equal to x plus 2x plus y. So this implies what? 3x plus y. So x I got 3y. Okay? X I got 3y. But this is not enough to state the values of x and y. Use the second condition. These three terms are in GP. What is the condition for that? This middle one is the geometric mean, you know. So xy plus 5 whole square will be y plus 1 whole square. Am I clear? If three terms are in GP, then the second term square will be equal to the first and the third. I am using that only. Take square root of two sides. Y plus 1, x plus 1. Now there is a chance. This is your equation 1 and this is 2. Solve for x and y from these two equations. How to? You take this x equal to 3y and substitute there. From 1 and 2, put x equal to 3y. 3y square plus 5 equal to 3y plus 1. Isn't it? So 3y square what do you get? 3y square plus 5, 3y square plus 4y plus 1. These two get cancelled. So 4y 4, y equal to 1. And this implies x equal to 3. Once you get x3 and y1, then first series you can write easily. And second one also. So AP series is what? X plus 2y, this means 3, x plus 2y is what? 5 and 2x plus y, 7. API got? Then GP will be what? Y plus 1 whole square, 4, xy plus 5, 8 and x plus 1 whole square, that is 16. Clear? There in GP. Understood? Hope all of you have understood. Then go for next one. Sum of an infinite GP common ratio less than 1 is 32. Sum of the first two terms is 24. So infinite GP you take this way, AR square like this. Sum of infinite GP, this is what? Is 32. And sum of first two terms, A plus AR is 24. Okay? So this implies A equal to 32, 1 minus R. And here A equal to 24 by R plus 1. Isn't it? I'm just going to compare. They ask you to find the series. So this series can be obtained if you can eliminate A from these two. Just eliminate. How to eliminate? To eliminate, we are comparing A from 1 and 2. What do you get? 32, 1 minus R. So cross multiply. 8, 4, 3. So 1 minus R square is 3 by 4. R square 1 minus 3 by 4 is 1 by 4. So how much is R? R is equal to 1 by 2. You take plus minus. They haven't told that it is positive. No, sum of two terms given. First two terms 24 given. So R you will take not plus minus half, R you take half. For R equal to half, A going to be what? Half plus 1. 24 into 2 by 3. That is 16. Not a difficult sum. Just use the formula and get it. First term of an infinite GP is 1 and each term is twice the sum of succeeding terms. Again on infinite GP I have asked. A is 1 and very interestingly one term is twice the succeeding term. This is possible for infinite GP only as series of terms goes on decreasing. I can start from here. The first term A equal to 2 into sum of the succeeding terms. Got it? But this is also infinite GP. This is infinite GP, this one also infinite GP. What is its sum? A by 1 minus R. So this implies A equal to twice AR by A get cancelled. Since A not equal to 0, therefore 2R equal to 1 minus R, 3R equal to 1. So R you got 1/3. And first term given is 1. So AR square. This is the series. Okay. So by following the previous session on GP and this session, I hope all of you can approach sums from any study material. My study material and the platform where I am going to share, I will have within a few days. I'll share the link, you can download from there. See you again. Next session I am coming with summation of series in AP and GP. Thank you for staying with me.